is a normal distribution question from the June 2022 A2 Applied Maths paper, and this I think then is question 7, so let's take a wee look. In healthy adults, systolic blood pressure is normally distributed with a mean of 112 and standard deviation of 10. Find the probability that a healthy adult selected at random has a systolic blood pressure of less than 125. So many different ways of doing these things these days because of the era of a calculator. So we have the our distribution, which I guess I'm calling V, and it's our normal distribution, and our mean is 112, and our standard deviation is 10, and our variance then is going to be 100. So what do we know? We know that our mu is 112. We know our sigma is 10, and for this part then our x is going to be 125. So here's our normal distribution. That's 112, which is our mean. Standard deviation is 10, and we're looking for find the probability that healthy adults selected systolic blood pressure is less than 125. Hopefully we can all see that 125 is bigger than 112, so we're looking for this area here. So if you're using the slow method, we're trying to find the area of whenever the kind of 125 or less, and we get our z value from there. And I'm actually going to use the tables that'll show you how we do it in the calculator then as well. So we're looking for a probability that B is less than 125, and so our z value is going to be x minus mu over sigma. In this scenario then it's 125 take away 112 over 10, and so it's going to be 1.3. So we're trying to find then our area. Whenever our z value is 1.3, and if we look that up, so there's 1.3 there, and it's 0.9032. The three significant figures, 903. Let's see how we do it in the calculator. Hopefully this is clear enough in the calculator. So we want to go menu and 7, and you want to press number 2 here. Hopefully that's clear enough. And then we put in our values. Our lower value is 0 because we're kind of all the way down then at the bottom. And our upper value, let's see, lower value is 0. Our upper value is 125. Our sigma, as we know, was 10. And our value of mu then is 112. And if we hit equals, of course, we get 0.903 again. So another way then of getting our same value. Calculate the interquartile range of this distribution. So again, another couple of different ways of sorting this out. Our interquartile range is we're looking for our areas here. Where that is going to be our value. So I think our mean was 112, and we effectively want this bit to be 0.5. So I don't know if you can see, we want this area here then to be 0.75. This is just kind of one way of doing it. So if we go 0.75, and we can get our value then from there. So let's see. Let's see if that gives us our z value then. So we're looking for 0.75, so there's 0.7486, and we need to add 14 onto that. So that's going to be 0.67 to start with, and then we want to add 14, so that's then going to be a third of the way between the 4 and the 5, so it's going to be 4.3. So let me see if we can get 0.67 0.433 is what we're looking for. So Z is x minus mu all over sigma, 0.6743. X is the value we're looking for. Our mean is 112, and that's 10. So it's 6.743 is x minus 112. Adding 112 then onto this. Sorry, I'm in a... What did I count there? It's 118 then 0.74. Now we can do the same thing, but if we're kind of wise about this, we can kind of get a decent idea. I can see that's 112 and that's 118.74. So that distance there is going to be our kind of semi-interquartile range, that distance between there and there, which is 6.743. So if I just times that by 2, then that's actually going to give me a thing. You could work out your Q1. This is effectively working out our Q3 here, and you could work out your Q1 kind of at this end here, but it's going to be, the thing's symmetrical, so it's going to be 25% here and 25% here. So we can just do this 6.743. The other thing, of course, we could do to work out our actual value here is take away 6.743 from this value. And then that's going to get us our lower quartile, and just find the difference in between those two. But effectively our interquartile range going to be 6.743 times by 2. And that gives me 13.5. Now I don't have a unit here, let me see, mmHg, I think, where that means. Clinical trial is to be carried out involving healthy humans whose systolic blood pressure is below 104 or above 130. Estimate the percentage of healthy adults who are eligible for this trial. So we're looking for how many are below 104 or above 130. Again, our calculator will work this straight out for us, but we can kind of do a few sums in to work it out. So let's get our Z value then for 104. 104 minus 112 over 10, and that's going to be 0.8. And then for 130 minus 112 over 10, that's obviously a value then of 1.8. So we need to be careful with a couple of things here. The areas we're looking for kind of are on the either side of that. So the bits we're looking for are as follows. We're looking for this bit down here. So that's 104. There's our 112. And then there's 130. So those are the two areas we're looking for here. So we're actually going to do 1 minus the Z value then of 1.8 to get that. So the area we're requiring here is 1 minus 1.8, which is 1 minus 0.9641. No 0.0359, and then this one again we're going to have to flip this using symmetry, so we go on the other side of there, and it's going to be 1 minus 0.8. value here, 0.8, 0.7881. Let me see, 2119. And if we add those two values together, then we get 0.2478. Now they're giving us another page for this. We're going to try and fit in the bottom. So therefore, percentage of eligible is going to be 24.8%. Just before we go, we're going to stick those values in, and let's see if we can get it to work. So menu 7 on my normal distribution, my lower value is 104, my upper value is 130. We need to be a wee bit careful here. That's 10, that's 112, and this is now finding, what this is going to find for us is this area here, 0.7522. So what we would need to do then is subtract that from 1, because it's worked out in between 104 and 130. So 0.7522, if I go back into the regular calculator and do 1 minus 0.7522, I get, of course, then the 24.8 again. And that's another way of us working out 24.8%, and is the correct answer.